I'll record here too. Great. All right. Welcome, Hannah, to the Biohacker Babes. Thanks for joining us today.
Thanks, Renee. I appreciate you having me. It's also glad to be with you, Lauren, as well.
Yes, so great to meet you.
Yeah, I'm super excited to chat about hopefully all things epigenetics, get into the weeds of it too. So just really excited to be here and appreciate you having me.
Yeah. Well, we first met in person at A4M last December, and we've chatted a few times since then. I just love the work you're doing. I think you're such an expert in this field. So I know our listeners are going to really enjoy this one. So for kind of like a big picture overview, so I think our audience has heard a little bit about us talk about, biological age versus chronological age, some of the different tests on the market, but we really haven't gotten to like the epigenetic methylation side of testing, TruDiagnostic, and what you bring with that. So I think just like big picture to kind of kick it off, how do epigenetics impact our health span and lifespan?
Oh yeah, that's a heavy loaded question to start off, but I love it. I love it. I want people to think of epigenetics just as a biomarker. That's all it is, right? Your listeners are very familiar with biomarkers by now. And if we just say that we can only measure biological aging outcomes through epigenetics, we would be doing epigenetics a huge disservice. So think of, cholesterol is a really good example. Back in the day, we only had cholesterol. Now we have HDL. Now we have LDL. Now we have particle size of HDL and LDL. Now we have particle size of other factors regarding cholesterol too. So it's this ever-growing outcome. And that's exactly what we're getting with epigenetics. So even though it started with biological aging, we're learning over time that it's almost able to predict anything as long as we have the data behind it. And we can talk about some of those new predictors as we get more into the weeds of it. But what we realize and it start with aging is that it is really going to be predictive of lifespan and health span. So you can get biological aging metrics that are kind of these overarching ages of your immune system, immune cell deconvolution methods, pace of aging, telomere length. So it's this all-encompassing kind of panel that gives you a baseline and kind of puts you at a starting point. And then you can make changes to hopefully modify those outcomes for the better, thus increasing your overall lifespan and health span too.
Yeah. I love that you call it a baseline because I think we could kind of label it all kinds of things. And this is certainly a driver of our podcast. It's like if we have information, then we have something to work off of. And I think with a lot of the testing out there, it can feel like a sentencing. Yeah, you said it's starting our journey. So this is where you begin and then we have opportunities. So how do we even sort through that information and figure out what's the path from there? Like, what are we being shown in terms of opportunities?
Yeah, I mean, the report is pretty heavy if you're new to this. I'll be completely honest, because we like to give you all of your data, right? We here at TruDiagnostic give you published validated algorithms as it relates to your health and want to give you a full picture, because if you really think about it, your cells are even aging at a different level compared to the cell right next to it. So you're aging in all of these different ways. And we really believe that you need to take this holistic kind of overarching approach and look at everything synergistically. And I'll be the first person to tell you, I'm obviously obsessed with epigenetics, but epigenetics isn't the complete picture either, right? You're probably doing a lot of multi-omic biomarker testing and even adding that in conjunction to, again, get this more whole body picture. But we have some algorithms that tell you, your overarching biological age, and that's what I've like coined your historical based aging process. So how you've been aging since your inception until now. That can be frustrating for a lot of people if they're older, because they're like, what the heck, I'm doing everything right. And that's when you enter like the pace of aging metric that tells you how quickly you're aging at this very moment in time, which can be more positive because it's a reflection of like, a 3-month, 6-month running average or so. So we're taking pieces of the puzzle and trying to put them together and guide you on the best recommendations from, lifestyle, supplement, medication, or procedural based perspective.
Yeah. I love the pacing because like biological age itself, I mean, I'm going to get into the different clocks and how we're measuring that, but like I've seen such a wide array of tests in ages. Like I've been as young as 18, I've been as old as 42, and I'm 36. So it's like, okay, so where am I really? But then the pace of aging really, it tells you what you're doing. I think you said like in the more recent time span, is that working? So like clearly in my teens and 20s, I did a lot more damage, I think, than I've done probably in my 30s as I've been a biohacker and been more of a health enthusiast. So I think the pace is a really exciting thing. So let's start with the basics, like the different clocks, the different generational clocks, to explain that, because we really haven't dove into that on the podcast.
Yes. Yeah, this is super important. I think this is a fundamental, again, understanding of epigenetics and what it is, what it means, because like you just said, Renee, there are a lot of companies out there who offer these biological age clocks. And what we know is epigenetic DNA methylation is going to be the most precise, accurate, sensitive way to measure it. But still, there's a lot of companies who use DNA methylation and epigenetics to report out a biological age. So what we then want to ask ourselves when looking, and it depends on, again, the outcome you wish to receive and maybe the application. But we'll start with the first generation clocks is what they're called. These really were the first clocks ever created. And they were created around 2011 and 2013, usually by Dr. Steve Horvath, which probably a lot of your listeners are familiar with too. He's out of UCLA. He's a pioneer in this field. He'll probably win a Nobel Prize for this work. I actually got to fly out and meet him before we started TruDiagnostic, which was pretty awesome. And he has a twin too, as a little fun fact. So he does a lot of experiments himself with biological aging.
I didn't know that.
Yeah. So little side note, but and he's great. We could not be where we are today in this field without him. However, what he did is he basically took biobank samples off of the shelf and he said, based on their epigenetic DNA methylation signatures, what is their chronological age? So he was trying to get closer and closer to the chronological age of that individual. And that's how we noticed that these epigenetic methylation markers can be predictive, because if you tested with a first generation clock and your age comes out, still a biological age, comes out older than your chronological age, you're at increased risk for almost every single disease, chronic disease, and death as well. Now, we don't care about chronological age in the medical community here, because everyone pretty much knows their birthday. But there are still really great applications. For example, they're used to identify the age of DNA at crime scenes if they're trying to locate a suspect. They're used for refugees to see if they're old enough to seek asylum. They're even used for people who may have been adopted and just don't have any birth records. So they still have applications, but I think from a biology perspective, they don't mean much.
Oh, that's interesting, because I was like, everyone knows their birthday, but oh my gosh, no, there are plenty of instances where that could be insanely helpful. Yeah.
So they have, their applications too. And again, that is really what started this really booming field. I think we're going through an epigenetics revolution currently. So, we couldn't be where we are without those. But what happened and when things really started to change was around 2018 and 2019. Dr. Morgan Levine, who I know you've had on the show previously, she was Dr. Steve Horvath's postdoc at UCLA. Then she went to Yale, and now she's at Altos Labs again with Dr. Steve Horvath. She really created what we coin these second generation clocks. And this is going to be different. And they're going to be a little bit better. And I'll tell you why. How they're creating these clocks is they're taking biobank samples off of the shelf, but in conjunction with those biobank samples, they're also grabbing a lot of other multi-omic data. So it could be for her clock in particular, she just used like a lot of blood-based values, like a typical CBC panel. So she's giving more power to her algorithm. And why and how we know those are better is because they are going to be more predictive of almost every single chronic disease and outcome compared to those first generation clocks. And that's the real point in the application of these clocks, is they have to be related to clinical outcomes or they're no use for us. We need to be able to know that we can change them, reverse them, and affect them, hopefully in a positive way. So Dr. Morgan Levine's PhenoAge is an example of a second generation clock. There is a DNA methylation telomere length second generation clock, where with the biobank samples in methylation, they also use telomere length, right, to be able to make a predictor of biological age based on your telomere. So you can really make a second generation clock by using any underlying other types of biomarkers.
Yeah, and telomere length, so that is still valuable. I know, I remember 10 years ago when I first did it, that was kind of that was the way to test your aging, and then it was but now we can also test for telomerase activity and but it seems like we've come a long way from that point.
Yeah.
It's still helpful.
Yeah, no, I'm glad you brought that up. So there's a paper just called Biological Age Predictors that came out in 2017 comparing all of the ways you can measure biological age. And what it said about telomeres is basically they've been very well validated, meaning they've been studied, so much, but they have extremely low predictive power or hazard ratio. So hazard ratio being, hey, how can we take a biological age predictor, telomere length in this case, and report out disease outcome? And it's very, very small. So we, TruDiagnostic actually offers a DNA methylation telomere length test. So we're quantifying it by looking at epigenetic methylations with that second generation clock I just mentioned. And it's going to be more of like a cardiovascular risk association and more of a senescent cell check-in as well. So we don't look at your biological age based on your telomere length because we have those better clocks to measure biological age. But if you're in a lower percentile, when we're comparing you to the population, we would say you have more senescent cells compared to people of your same chronological age, and you would want to take a senolytic to clear those out. So you're kind of like clearing out the shorter telomeres. We say it's like cutting the worst 5 people off of a basketball team. You're like getting rid of the bad stuff and kind of increasing your average, right? Which may be helpful in the long run.
Yeah, that's a good analogy. Okay.
Yeah.
Yeah, interesting. Okay, so it's only an additional thing for those people that may be at cardiovascular risk. What exactly, I guess I'm just curious exactly what the telomeres are showing in those conditions.
Yeah. So in terms of the telomeres themselves, our DNA methylation telomere length report is going to, I want to make sure that your listeners know that the DNA methylation telomere length report that we do are going to have 2.5 times the correlation value to age-related outcomes compared to your quantitative PCR-based testing. So even though we don't like telomeres as an age-related biomarker, the method by which we measure them are still going to be, better than your traditional CRP. Or excuse me, quantitative PCR. But the DNA methylation telomere length, they're going to outperform leukocyte telomere length in predicting things like time to coronary heart disease, time to congestive heart failure. It's going to have a stronger association with overall death and stronger association with predicting smoking history as well. So those are kind of I would say the heart outcomes that it's related to.
Okay. And are you overlaying it all with any blood chemistry or like calcium artery scores? Is that helpful?
That would definitely be helpful, I think, to create a better telomere length predictor of those outcomes, right? So we could definitely always be adding those blood-based values on top of it to, make better predictors.
Yeah. The more information, the better.
Yeah, exactly.
So with the senescent cells, if someone were to be taking a senolytic product, and we've talked about that on the show before, like Qualia Senolytics, something like that, would that skew the results? Like, do you need to take some time off of that if you're going to do the test?
Yeah, I mean, it's kind of like, hey, do I want to know how this supplement is affecting my telomere length, right? So if they wanted to understand that, then go ahead and take the test. If you want to get a really clean, hey, just how am I aging in general, probably, stop taking everything for 3 months or so and then take the test to get like a pure reading without anything else affecting it. But what we've seen in the trends within our data is people who take those senolytic combinations, like, your quercetin, fisetin, resveratrol, tyrosine, curcumin, they're going to be in higher percentiles of our population. They're going to have those longer telomere lengths compared to people of, their same chronological age.
Got it.
And what kind of frequency or duration over time are you seeing is producing the most results, or how quickly maybe can you see some results from senolytics?
Yeah, I think we can see them within a 6-month time frame, with that telomere data. We're still trying to figure out exactly what we're finding and kind of what molecule it's due to. So we've done a dasatinib and quercetin trial, and we've done I think dasatinib and fisetin, quercetin and fisetin. So I think we need to look at one single molecule rather than combining them together to see, okay, which one looks the best and what's the true signal that we're getting here.
Yeah, it's exciting. I mean, I wish that I had like all of the accessibility to all the tests all the time. I just would test, especially this new senolytic, which has to be cycled, right? The one we're taking 2 days out of the month. You're like, is it working?
Yeah. And I'm kind of curious as well to hear if you all have any thoughts on if you need to cycle it, I guess, or if you need to take it daily, right? I see some supplement companies saying, hey, you can take it daily, but it's at lower dosing. So I think we could even do kind of a dosing schedule and see how our testing is being affected by that as well. I think that'd be another interesting insight to gain or look into.
Yeah. Well, what is your opinion
Yeah.
on that? Because I guess my understanding, and a heck of a lot more, if we're constantly clearing those senescent cells, and it seems like we're kind of taking away the natural healing abilities of the body, right? Like we don't want to interfere too much.
Yeah, no, I totally agree with that, but I don't know then if that's like maybe doing lower dosing for 1 month on, 1 month off, right? Like still cycling it, but should we do the higher dosing for just a couple of days that in that particular month? So I don't know. I've always been curious about that. I think we still need the data to show us which one is more beneficial for, our own underlying biology.
Yeah.
I think Qualia has done some interesting research on that. And I mean, that's how they came to the 2 days on, 4 to 6 weeks off. I don't know the exact stuff that went on there, but I'll see if I can pull some of the research and put it in the show notes if anyone wants to look at that a little bit deeper. But also before we hit record, you mentioned a new study.
Yes.
Can you share more about that?
Exactly.
Breaking news.
Yeah, breaking news for everyone listening. So this is another second generation clock that TruDiagnostic has actually created. So we've actually been open for 3 years, starting in July of 2023. So it's been really exciting. And we've had this research study going on for those 3 years. So it's been a very long journey. But here within the next couple of months, we're getting ready to release what we call our omic M age. So kind of our multi-omic methylation biological age clock. And kind of every single second generation clock to date has only looked at one or maybe two other factors, other biomarkers. But here, what we did with our study is we took actually 5,000 biobank samples, and we did this in collaboration with Harvard. Dr. Jessica Lasky-Sue is our metabolomics queen over there. She's absolutely amazing. But we took these 5,000 samples. We ran their epigenetics through TruDiagnostic. We ran their full genomic panel, so looking at their genetic variants. We ran about 2,500 metabolites on them as well, and about 8,000 untargeted proteomic analyses, along with a little bit of transcriptomics and then their phenomic outcomes as well. So the biobank at Harvard was very, very valuable to us because we're able to get data of, what disease did this person end up having? When did they maybe pass away? So we can even predict those things with this specific data set. And in particular, really what we found is we created a clock that's going to be the best at predicting, all sorts of different outcomes. The algorithm, that omic M age in particular, there's about 39 clinical values that we include in the production out of that omic age. So I just named like thousands and thousands of, proteins, metabolites, et cetera. The ones that were most significant in terms of predicting age would be those 39. And I don't know all 39 of them off the top of my head, but we're able to do some really cool things with that data set. Essentially, again, the point is being able to predict, measure, and then take action. So knowing those 39, clinical values, metabolites, proteins that make up that omic age and affect that omic age, we'll be able to go into each of those separately and say, okay, maybe we need to take more of this supplement or, perform this routine, et cetera, et cetera. And those 39 things that I keep talking about, those are going to be called MRSs, or methylation risk scores. Basically meaning it's like a combination of DNA methylation markers and a weighted sum or average for that particular outcome. So for example, we have a methylation risk score of HbA1c, where we can predict your HbA1c just looking at DNA epigenetic methylation data. So we're really going to be able to dive into a lot of these other biomarkers, which is why epigenetics is so exciting and kind of what we were talking about at the beginning, using it as more of a biomarker. Again, I know your audience is very, very familiar with things like NAD biomarkers, so NMN, NR, plasminogens, things like spermidine, your omega levels. We'll be able to quantify all of those by just looking at this epigenetic data.
Oh, interesting. So even before doing blood chemistry, you're like the fortune teller.
Exactly right. Yeah, that's a good way to put it. So I know that study, and again, don't quote me on this. I need to get up to date on all of the news. I know that study just came out, I think regarding spermidine, that you're not able to measure spermidine very well in plasma levels, right? Before and after supplementation, which is not helpful. So actually the DNA epigenetic methylation we found is very predictive of spermidine levels. So we can do your test, before and after supplementation and see if that's actually increasing those spermidine levels in the blood. So again, the epigenetic methylation markers are so specific to that one person. It's fairly cheap to do. Your data is really ever growing. And then it's more of, again, a predictor of what's going on right now. And your epigenetics obviously does change, but it's stable enough to tell you what's going on within, that 3 to 6 month running average to see if maybe you need additional supplementation or, maybe you need to take some supplementation away. So we're going to get really, really personalized in the future here.
Yeah. That's so exciting.
Do you see that becoming more accessible than serum testing?
I do. There are some experts that quote, the epigenetic methylation testing in general will replace like 60 to 70% of what like even your GP is doing, which is crazy to say. I think they say like a decade. I think it'll be like 2 or 3 decades before we see that, because let's be real, things move really, really slow. And then for people to be able to change and, adopt this type of testing, I think it'll take longer too. So I do see it becoming more affordable, just because I think the insights are going to add more value over time. So I think, for how quickly we can get results back, it just being, a finger prick of a blood sample essentially, you're always going to the office to take blood and do other things anyway. So kind of just sending that in, getting those results very quick, and them being actionable too.
Mm-hmm. Yeah. Yeah. Side note, since you mentioned spermidine, I'm curious. I mean, because I believe spermidine impacts, I think it's 9 out of the 12 hallmarks of aging, which is, I mean, that's like a pretty insane percentage. Do you feel like spermidine is like potentially one of the top supplements we can be taking for biological age?
Yeah, I love spermidine. I think it's great. I take it myself, but I think the research is just so limited. That's why, epigenetics, as equally as exciting as it can be, so frustrating because it's so new, that we need kind of these clinical interventional trials and kind of the before and afters to see that. So I would say we're definitely still learning. I wish I could give you a better answer.
Yeah, no, that's great.
I'm just so interested and curious because you're so steeped in the research. Like, then do you ever get these like kind of intuitive pulls or feelings about things, or are you just beholden to let's wait for the conclusion?
Yeah, I mean, I get so excited about everything. So the great thing about TruDiagnostic is we mostly work with healthcare providers that are, in the integrative, functional, preventative, whatever you'd like to call it, anti-aging space. So they have a lot of data, that comes along with their patients. So we're able to see like subjectively what's working, maybe before it becomes objective in some type of clinical trial. There are some things that are like really obvious, like, DHEA works really well to mitigate those glucocorticoid receptor elements and lower your cortisol levels. And we think NMN and NR looks really, really good right now. For biological aging, there's no published interventional trials quite yet. I think some are starting to begin. We're really huge fans of rapamycin. I know a lot of people do it. I
was going to ask that.
Yeah. We're going to ask about rapamycin.
I want to know about rapamycin for animals. Thoughts?
My dog gets it. I give it to my dog.
Help me. I want to give my dog rapamycin.
Wow.
She's a big old Bernese Mountain dog. I think they have the shortest lifespan of any dog. It's like so sad. It's like 6 to 7 years, I think. But yeah, those research trials have been well validated. Matt Kaberlein from Washington State University, they do the dog aging project as well. They see an increase in lifespan of like 30% in dogs in general. So I'll give my dog, she likes it, put it in a little piece of cheese and she gets excited.
Wow.
Oh my gosh.
Lucky.
So yeah.
How old is your dog?
She'll be like 3 here coming up. Yeah. In a couple months. So she's the best. I love animals. They're just, great. So yeah, Lauren, you could give your dog some rapamycin if you can get a script.
That's the next step. How do I get a script? Okay.
Yeah.
But good to know. I was very curious to hear your opinion.
So
lucky dog.
Stay tuned too, because people care more about their pets than they do like their best friend. There are a lot of companies I think you'll see come out that are creating prescriptions for animals, and then even like biological age testing for animals and dogs in particular as well. So I think you'll be seeing some of that very soon too.
Very exciting.
Mm-hmm. Oh my gosh. I did not even know this was a thing.
Yeah.
With animals.
There are some clocks out there, but they're first generation clocks. And,
Okay.
that'd be helpful maybe if you adopted your dog, right? And you wanted to know how old it was, but just, think about those clocks and what you want to know about your dog.
Yeah.
What else do you do, since we're on the topic of your dog? And I think you're probably really supporting longevity. What else to support good health?
Yeah. I think, Renee, you mentioned this before we hopped on the call as well. I've done more report reviews. I'm claiming the title than anyone else in the world as it relates to epigenetics, for TruDiagnostic reporting, of course. The people who have the best aging, and what I try to adopt more of, is just like doing the lifestyle factors right. Like I'm telling you, like no one wants to hear that. It's boring. It's intuitive. But the people who are doing the lifestyle things right, they have the best aging. Like those people who just have a simple life. But in particular, I definitely practice caloric restriction. There is a trial called the calorie randomized controlled trial. It's spelled a little weird. It's like CALERIE. That just got published in Nature at the beginning of this year, like February 2023. And that's just a 10% overall caloric restriction in healthy non-obese adults. So it's not much. They attempted 25%. No one could do 25%. And so they lowered it. And the Dunedin pace was actually the only clock, and we can talk about that one later too, to capture that change, to slow down the Dunedin pace. So again, it's not necessarily like time restricted feeding or intermittent fasting, which again, still has value depending on your personal goals. It's just reducing your overall caloric intake.
10%.
Okay.
Interesting.
And
So how someone, go ahead. I'm just curious how someone would approach that.
Yeah. Is that a daily 10%, or can we do 1 week on, 1 week off kind of thing?
Yeah, it would have to be continuous. So that study went on for 2 years. And again, that study seems so simple. You're probably thinking like, what the heck, Hannah? Like, duh, caloric restriction helps. And like, we actually don't know, right? We can't, it'd be so unethical to like restrict babies of their calories when they're born to when we like become older, right? So what they did in the study is they said, wait, we have these really cool biological age clocks, the pace of aging. Let's see if it captures the change. And the Dunedin pace, like I said, was able to capture it. So it's a really proof of concept fundamental study. And what I learned from Dr. Daniel Belsky out of Columbia University, who does a lot of the research within the Dunedin pace, is they're doing a 10-year follow-up of that study. So that's the beauty of it, is we can do follow-ups and kind of see how those cohorts are performing.
I mean, it's a much more reasonable approach, 10%, but I'm just so curious because it feels like it's just been lobbed around in the industry and research. People are like, it's everything. And then you have people like Peter Attia, they're like, don't believe it as much as I did. But like, if we really clarify what he's talking about, it's this swing from a massive amount of fasting to something more reasonable. And I think probably 10% fits in there. But then people go like, what does that mean to me?
Yeah. And again, like don't perform caloric restriction if you're pregnant, breastfeeding, if you're trying to, meet a certain muscle mass or you have these certain goals. I will say, Lauren, Peter Attia, I don't think he knows about the calorie randomized control trial, because I would say his outlook on biological age clocks, I don't think he's completely convinced yet. But I don't think he knows much about the Dunedin pace and the calorie randomized control trial. I've tried to reach out too, but I haven't heard back yet. So I'll keep you all updated.
Okay. Keep knocking on that door, because I don't know. I know a lot of clients come to me and they're just hanging on every word that he has and says. So I think it's really valuable, and hopefully he accepts that information.
We'll see. But caloric restriction is great. Kind of another lifestyle factor, and we can move on to maybe what we see more supplement medication and procedural based wise though is stress. Like I know that's so simple as well. I'm like naturally just abolish stress. So that one is a little closer to home for me. Epigenetics has a really massive psychosocial analysis portion of what drives it. So if you can reduce stress levels, if you can have more quality relationships over quantity relationships, if you can control your thoughts. I know not everyone has an internal monologue, but if you can, throughout the day, you can kind of say, oh, like, why'd I do this? Or why'd I do that? Or you didn't get this done, right? Like talking bad to yourself, like that even influences your epigenetics and how your genes are expressed. So trying to be we may not always be able to control our emotions, but trying to, I guess, can also have like a better effect on kind of your aging outcomes too.
Yeah. Real quick. So the Dunedin pace, just in case anyone is not familiar with that, can you do a quick highlight of what that's looking at?
Absolutely. Yeah. This is my favorite one to talk about actually. So We just define first, second generation clocks. There's a third generation clock, and this is going to be the Dunedin pace, or your pace of aging. And the way by which this algorithm was designed is very, very unique. So they took about 1,000 people from Dunedin, New Zealand. That's why it's called that weird name. There's also Dunedin, Florida. And they were born in 1972 and 1973. So it's just a birth cohort. They see these newborns and they're following them throughout their entire life. Well, they're 52 years old today, and they have a 96% retention rate, which is like insane. Like a good one in the States is like 60% if you're lucky. So it's just a really unique study. But what they did in that study is at 4 different points in their life, and they're taking a 5th follow-up right now, they took a lot of just like body function biomarkers, where they did like different DEXA scans, simple things like BMI. They did like dental imaging and gum health. They're looking at pulmonary, cardiac, so all of these different things. And then also like their blood-based values, typical CBC panel. And they were able to create this algorithm of how quickly you're aging at this very moment in time, biologically, for every one chronological year, because they have all of that longitudinal data. So think of it almost like a speedometer. I always end up like doing that with my arm. It's like a speedometer. It's a value between 0.6 and 1.4. So if you're right in the middle at 1, you're kind of aging 1 biological year for every 1 chronological year. If you're at 1.4, you're aging 40% quicker. If you're at 0.6, you're aging 40% slower. And this algorithm, I think by far, we'll see how it matches up to our omic age, but right now, before we launch that, it is the gold standard for measuring the effectiveness of just how you're aging right now, how you respond to certain interventions. It's the most related to mortality and morbidity. It is going to be representative of a lot of quality of life-based metrics. So people who have a faster pace of aging, they have like weaker grip strength, slower gait speed, worse cognitive decline over time. They even have faces that are rated as older looking. Like Renee, I think I showed you that photo where like everyone's 45 years old chronologically, but like the oldest people who have a faster Dunedin pace, they look so much older phenotypically than like the 10 average slowest Dunedin pacers. So it's a really cool image to see. So it's going to be related to, all of these different outcomes, but the story behind it's great. Our collaborators at Duke and Columbia University are absolutely amazing. And they'll continue to follow up with the group. And I think as long as like funding allows, they'll keep measuring them as time goes on.
That's so cool.
So with that min-max, like the bookends, the 0.6 and the 1.4, is that you've reached those bookends just based off of what you've seen, or you've predicted that you can't possibly go beyond?
So it would be the first one you said. So I get this question all the time, and I always said, I don't know. So I finally asked Dr. Daniel Belsky about this, and he said, basically that was just what that cohort allowed. So
got it.
For like simplicity's sake, yes, those are like the end bounds, but they don't have to be. Like if another cohort was performed and you kind of took those same data points, you could get a little bit slower, you could be a little bit faster too. That's just kind of what they saw in that particular study. But I will say that study, so the training data set of everyone being in New Zealand, it really helped by reducing exposures. Everyone was going through kind of the same things in their life. So that's the uniqueness of that data set, but it has been validated in a lot of other populations. So that's what really matters with these algorithms is, hey, does it work in other ethnicities, male, female, other chronological ages, right? It has to work in kind of all of those different aspects and areas.
Yeah. I wonder if like someone like Brian Johnson, is he 0.4? Like, how extreme could we get?
0.6, right?
Yeah, I've heard he's 0.6, but I didn't know if that's just because it doesn't go lower. But
so
that's the best score.
No, that's a good point. His score in particular. So you're kind of referring to like the rejuvenation Olympics that we're doing, where like the goal is to never cross the finish line. But yeah, we started that with Brian Johnson, and we didn't know he was originally testing. He was just like doing our tests on the side and then found these amazing results. But what we're actually quantifying is you have to have 3 Dunedin pace tests, and then the first and third test have to be at least 6 months apart from each other. So what was so impressive with his is like the reversal he saw based on his chronological age, that percentage of change, because it's more impressive for someone who's 100 years old to be at 0.6 than like a 20-year-old to be at 0.6. So the Dunedin pace like slightly increases as we become older chronologically.
Any kind of gross conclusions about gender or age closer to that 0.6? Are you seeing more females, or I guess age, obviously we would throw that up, but what about gender?
Yeah, I'll have to do an analysis with the Dunedin pace. I don't want to say I would assume that it would be the same, but like for the overarching biological ages, like men are just older, like period. I see that all the time. Just because there's that sex paradox where men typically, die younger and they just age quicker compared to women. So I'll have to see if it's the same for the Dunedin pace. I will say I was doing like a report review one week with 2 women, and they had a Dunedin pace of like 1.35. And I was like, should I cancel these calls? I'm so scared to talk to them. I was like, did we do something wrong? I checked QA/QC. Everything looked great. Their sample was in perfect condition. I found out they were both pregnant. So we see like massive increases in Dunedin pace, which we knew that. I just didn't know they were pregnant. So I was very relieved when I hopped on the call and they told me that. And I was like, wow, that's the highest I've ever seen.
Is that a temporary swing?
It is. Yeah. So there's a really good paper out there called I think it's just biological ages increased upon stress and restored, or increased with stress and restored upon recovery. That's by Dr. Jesse Pokanik. He's out of Harvard University, and he looked at severe COVID-19, unelected surgeries, and then pregnancy. And we do see increases with all 3 of those events, but kind of after time goes on, you see those completely go back to baseline.
Okay. So what else can we be doing to slow the pace down? What are the other big things besides calorie restriction?
Yeah. So that's, I think, from a lifestyle perspective, I'll just go over them very quickly. No smoking, no alcohol consumption whatsoever, improve insulin sensitivity, reduce your toxic load and exposure. That's actually huge. We can tell you where you live basically, like, by your zip code, essentially, from looking at your epigenetic methylation markers. So they're so representative of kind of the exposures you surround yourself with. So obviously we can't like pick up and move where we live. But you could be in control of like, hey, do I have a water filter? Do I have a shower filter? Let me look at like the ingredients, no plastic bottles, right? Using like all glass, looking at your cleaning supplies, like just trying to do like a internal like household detox load is always a good idea to try and be in control of that as much as possible. So that's a pretty big one too.
Okay. Now,
I wish that I had a test after living in New York for as long as I have. And then I actually spent the last 18 months in Maryland. And I assumed that when I went to Maryland that my sleep would be deeper, just overall quality of sleep would be better. And I wasn't seeing any massive changes in my data, but I'm curious if I had done the PACE test before and after, if there would have been more cellular changes.
Yeah, I definitely think so. And again, I'm assuming, do you live in like the city in New York?
Yeah,
like,
the city, just all the pollution.
No, so the reason I say that too, I was just talking about this with someone last night, is also like the amount of green space you surround yourself with is actually better for epigenetics too. So one of the studies they did in particular, it was looking at children who were born with like more green space around them, and not necessarily in green space, like you could bring plants in your house or office or whatnot. And the children who were surrounded by plants and things, as they became older, they actually had epigenetic methylation changes. And what they did as an outcome test was they had a higher IQ. So that's like some pretty crazy data. And there are a couple other studies just showing, increased green spaces have, better epigenetic signature markings as well.
Plants make you smarter. I'm going to go shopping after this.
That's what I said. I said, that's my excuse to get more plants. Like I have so many in my house.
Yeah. Oh man, I don't have any plants. It's terrible because my cats will eat. Yeah. I mean, I think Lauren, you had the idea that I should like hang them from the ceiling or something so that the cats can't get to them.
Knowing your cats, it's still going to be a bad idea.
Yeah. So I actually
fly through the air and catch them.
They probably would.
Jump from the bookshelf back there and exactly. Get your plants. I had a Roomba get my plant actually, and like the glass and everything just like fell and the dirt was everywhere when I came home one day. I think it was a pathos, so it was like so long and I think it got stuck in the lead. Oh, no. I was like, what in the world? Yeah, it was like kind of a little horror story.
Oh shoot. I love those. I love the pathos. Oh
yeah. Well, the alcohol though, I have to ask. So you said no alcohol consumption. And I this is the big debate because, every once in a while you hear a study that says, women that have 2 to 3 drinks per week, seem to live longer than those that have 7+ or 0. And I don't know how much of that is because those people tend to be maybe more social, less lonely, have more community. Like, of course, there's other factors, but you said no alcohol. You see that damaging.
So Morgan Levine was on this original paper. It came out like, I don't even know, a while ago, meaning like probably 4 to 5 years ago in epigenetic years. But she published on just like an association-based paper. So like more chicken equals better, like intrinsic biological aging and some things like that. And they said, hey, one glass of wine a week or 1 12-ounce can of beer a week actually has shown better epigenetic aging. So we would tell people that at the beginning. We were like, here's the paper, here's the data, here's the association. But what we've learned now, and from just seeing it in our study, and now there's a lot of papers on like, tobacco, marijuana, kind of alcohol associations and epigenetics. We don't recommend any at all. We just see all around negative effects. Now, in particular, people who have alcohol use disorder, which is 7 drinks a week for women, double that for men, they have a 2.22 year intrinsic epigenetic age acceleration. Which again, like if you're not a drinker, but if you meet up with friends in a weekend, I mean, as a woman, you could easily drink like, 7 drinks or a glass of wine every night. Like if you have a glass of wine every night with your dinner, like you technically, I guess, have alcohol use disorder, right? You meet that threshold. So, it can add up relatively quickly. And I think, Renee, you make a good point. Hey, people who drink, this glass of wine once a week, like they live longer. Like those are probably the people who, like you said, have a really good social life. They're having quality conversations. Maybe they're like living more of that Mediterranean blue zone-y diet, and they're like low stress. And so I think we need to understand kind of more of those social determinants and those aspects too, to really kind of make a gamble there.
So many variables. I'm just curious, like how much can we hack this? Like if we're really controlling for all variables and we're upregulating detoxification, maybe taking all the supplements to kind of clear the acetaldehydes and the toxins, maybe taking, B vitamins, molybdenum, binders. How much can we really help ourselves, do you think? Or is it just too personal and too many variables to assess?
So I think we can. I think we can help ourselves. TruDiagnostic, we actually released a really cool report. We can tell you how much you've drank or smoked across your entire lifetime by looking at your epigenetics. So when you're like, wait a second, how can we hack this? So basically what we do is this. We compare, it's funny, what you say you drink on your intake survey with what your methylation tells us. So we don't use any survey data for our reports, but in this one we compare because then it adds value. So what we're comparing against, one of those MRSs, those methylation risk scores, which is a combination of methylation signatures that are predictive of alcohol use. And then we're putting them in a percentile to say, where do you compare with other people who say they drink this amount? So I've done report reviews with some of my healthcare providers who say they drink regularly and they're in like the 98th percentile. And they're like, yep, I have a couple glasses of wine with dinner every single night. There are some who say, oh, I only drink once. They're still in like the 70th percentile. I'm like, hey, do you drink a little bit more than, once per week? And they're like, yeah, you caught me type of thing. But we can reverse it. Like that's the benefit of these epigenetic methylation markers. To your point, Lauren, I don't think we know what to do yet to exactly reverse it. But people who stop drinking, I mean, we'll still be able to pick, like I had a provider who stopped drinking for like a year and a half or so. And so they put never, they haven't drank. But I mean, we could still pick up a little bit of methylation signature on them, just because again, it's going to leave an imprint on your epigenetic DNA methylation for some time.
Okay.
Very fascinating, exciting.
That's big.
Yeah. Like I would love to see my report.
I love the 20s. Truth serum. I'm like, you're lying.
Yeah. Well, also, the other insight, because people are like, well, how is this helpful? And I'm like, well, it's not just like you're lying and pointing fingers, but if they're telling the truth and they're still in a higher percentile, they may have a low tolerance to alcohol or low threshold. And I've found that to be so true when I'm doing these report reviews. They're like, yeah, I drink one glass and I'm like, oh, quote unquote, lightweight, or like, I have to sit down, or, I get massive hangovers on one drink. And I'm like, yeah, your methylation is saying we're still picking up a signature, even though you don't drink. So you may want to dial down on alcohol consumption just generally.
Right.
That makes sense. Okay. So the signature could have equal impacts in 2 different people, depending on the tolerance.
Yeah, correct. Mm-hmm.
Yeah. That makes sense. I mean, I have like 1 or 2 drinks and I definitely can feel it the next day. And then I have a friend that can drink like, I mean, he's a guy, so he can drink more naturally, but
Right. Yeah.
he can drink like 2 bottles of wine in one night. And I'm like,
No,
"Whew."
thank you.
Yeah,
Maybe not something
crazy.
to brag about,
So
Yeah.
but
yeah,
slightly enviable. Slightly.
yeah.
What
So
about, oh, we have so many questions. We're
I
competing
know.
here. Can we talk
I'll let
about
you
sleep
go.
deprivation and how that's showing up?
Yes. Sleep. Gosh, this is a hard one. It has not been studied much, which is so crazy to me because now we have like the wearables and the tracking data, and we can talk about how wearables and epigenetics can be measured afterwards too. But there's like only a few select studies on sleep. There's one in the a women's health initiative study where they basically looked at quality and quantity sleep. And in terms of quality, they looked at different insomnia-based events throughout the night. And what they noticed, again, more of an association. I think we need more data, but they basically just noticed that people who have more insomnia-related events are going to have poor sleep. They didn't even find a connection between quantity of sleep, like number of hours of sleep, and we know that that is like essential to good health, right? I mean, I guess for most people, I would say so. I do know some researchers and people. We had one of our Cornell researchers here in our lab a couple weeks ago, and he said, "Yeah, I've always just slept, only 3 hours a night, and I'm good to go." And I just stared at him and couldn't believe him. I mean, he was telling the dead truth. He's like one of the smartest people I've ever met. So I think all that being said, there needs to be more studies on sleep, but obviously it has to be a huge component.
Yeah.
3 hours.
Yeah.
I want to follow this guy around and watch everything he does.
Yeah, it did not add up, but I was like, okay, you're very intelligent person. I'm wondering about that too.
Yeah. I mean, I've heard that with some people with like 5 or 6 hours. They're like, my sleep is great.
Yeah.
I wake up without an alarm. I have energy all day. Like, why do I need to sleep more than the 6 hours if I feel amazing? I'm like, hard to argue that.
He has to be taking a nap. Probably just didn't tell us that. 3 hours of sleep at night and then maybe a nap in the middle of the day.
Yeah, right.
He's doing another 4 hours in the afternoon.
Yeah.
Yeah, we need to get eyes on him. Quick pivot to something I had mentioned before we hit record, the intergenerational component. Like how much of what our grandmother did is impacting us?
Yeah. So Renee, what you're talking about, it's a mouthful. It's the transgenerational epigenetic inheritance. Yeah. Transgenerational epigenetic inheritance. But yeah, so this is a really interesting idea that even though our epigenetic methylation markers can change, there's a huge heritable genetic component to it. So, if our grandmother smoked, that's going to leave a negative impact on us. If our grandmother ate really well and didn't smoke, that's going to leave a positive impact on us. So from a human study perspective and what research shows is we're able to go back like 3 generations. Now, I was also talking about Dr. Michael Skinner at the beginning, who's at a Washington State University, and he has coined that term. He's dedicated his life work to this. And when I originally heard him speak at PLMI in Seattle with Dr. Jeffrey Bland last year, I was scared. Like I wanted to cry because basically what he's doing is he's looking at animal models. I want to make that clear. He can now trace from an F0 generation all the way out to F20 different signatures of toxins, essentially. And why that matters is because, number one, the EPA, the Environmental Protection Agency, doesn't have any laws against generational based toxics. And that's going to be very hard to change here in the US. Europe, they're working on it in Europe and kind of maybe almost doing things too quickly, changing rules and regulations too fast. But I'll give one example. 50 years ago, when we had a malaria outbreak, they gave everyone who had malaria DDT, and that healed them. They were good to go. What we realize now, 50 years later, is that people who have taken DDT as it's a toxin, actually have increases of having obesity. And 50 years later, we're now going through like an obesity epidemic, right? So it's those connections where like, oh, we don't think about it. It cured malaria. It's all good. Well, what's the actual negative impact? And, those people who are going to have DDT, they're going to have a signature on their epigenetic methylation. they're going to be more likely to become obese. They're going to pass that down to their children. Children's going to pass that down to their grandchildren. So those connections are wild. Like that topic just absolutely blows my mind.
Yeah.
How do you change that narrative and not be terrified and turn it into action? Maybe just even for yourself. Some personal advice.
So yeah, I mean, I asked Dr. Skinner that. He's great to talk to. He's funny. I asked him that as well. I said, hey, like, are we all doomed? Like, what do we do? And he's like, you can change it to an extent, the epigenetics that like you're in control for, but there are some epigenetic signatures that are so ingrained into like our DNA that like you're not going to be able to get rid of it fully, right? And that just put like the nail in the coffin. I was like, tell me something positive. But he was saying, no, I mean, there's certain signatures that, will not change. And there are some exceptions for it. Yeah. Epigenetic methylation markers that can't change, being some of the transgenerational ones.
Yeah. When I think about this, I think about our great aunt, Lauren. We talk about her a lot on the show because she's 98 now. 90, she'll be 99 this year.
98 and a half.
Aw.
90 and a half. And she's kind of the anomaly. Like she has not really eaten that great. She's never been in a gym, I don't believe. I think probably lower stress, so I would love to we should do a TruDiagnostic test on her. It'd be really interesting to see. But anyways, I think about like, so she's 2 generations above us, right? But then 2 generations above her, like her grandmother, how different was the planet then, with like toxins and things. So I wonder if like maybe because of that age gap, she's able to get by with doing less versus now our generation, we have to do all the biohacks. We have to optimize all the things because we're kind of fighting a bigger battle than maybe she did for 98 years.
Yeah. That's interesting. I mean, it makes sense. Yeah. I think it makes sense. And, I think the positive takeaway from all of this is like, you're still in the driver's seat. Like you still are in control of a lot of your epigenetics. You can't control what your mother did, what your grandmother did. Right. We may never know, like, what our mothers did, what our grandmothers did in their early youth as well. So you're still in control for a lot of it. And, maybe they are passing on signatures that are good. I know I don't have children right now. I mean, maybe in the future, I don't know, but like, I don't think of my future children every day or grandchildren every day, right? When I'm doing things, but I think it's more of like the environment we need to pay attention to, right? And again, kind of like those rules and regulations and people being involved more in like the government policies and changes, which again, I know people probably think is a little bit more boring, but like those are the things that are going to move the needle when it comes to a lot of those toxics and exposures that, are again, less in our control.
So you're saying just being more active and like signing petitions, something connected to like EWG or what other? Engage in?
Yeah, I think so. I think and more, like more research being done on like, like certain pesticides or, what's happening, where's our food being farmed at, right? Like really diving into more of like sources. Just because it says organic on it, is it really organic? Like you go down the conversation about like, where do you get your eggs from? Free range, cage, like whatnot. So I think being more, aware of that probably, and just like, supporting local, but understanding like what local is doing in the first place, right? Kind of making sure that you're getting the high quality foods that we want to give our bodies, if that's kind of the route you take.
Yeah. Can I ask you, do you have any comment on lab grown meat?
Oh, I don't know. I haven't really dove into that a lot. What's everyone saying on that?
Well, I think we're of the opinion that regenerative farming is something that needs more attention because the soil provides nutrients, like it takes care of the environment, this circle of life, whereas lab grown meat is just cutting that process off entirely and trying to recreate nutrients in a lab setting. Even if you can have those nutrients, we're losing kind of the consciousness of the planet and energetics. I guess that could get a little woo-woo, but
I mean, again, I wouldn't eat it. I'm saying that right now. I probably wouldn't do it.
Yeah.
but yeah, I think you take away a lot of like the soil and like the natural component and kind of that entire cycle. Just, I totally agree with you on that, Lauren. And also like where the animals again are feeding, what kind of farms are they at? Like if you take a cow in California versus like Lexington, Kentucky, the soil is going to be different. Like you're going to get different meat from that, right? It's like the same thing with like yeast and why like it doesn't really taste different, but like why sourdough can be different in like different states, right? Like your environment is going to change. I just don't think people realize how much science goes into it and kind of all of those life cycles. Like I'm picturing an image from like my biology book where it's like you can see the ground and then the grass and then it going to the cow and then, you know, out of the cow, whatever. But yeah, I don't know. I probably wouldn't recommend it. Conclusion.
Okay. Yeah. Thank you for that. Well, I'm like really excited to pay attention to see if we can see kind of these methylation signatures once people start eating that. I'm a little terrified of it.
Yeah, I think dietary wise too, to maybe add more than just a caloric restriction. One study they done on the DASH diet, the dietary approaches to stop hypertension. It's just quality food, more whole grains, legumes, red less meat, less sugar sweetened beverages, less sodium, more fruits, more veggies. Again, pretty intuitive. We're doing a study right now with Dr. Joel Furman on the nutritarian diet with the G-bomb. So that apparently they're hypothesizing, of course, that it's going to be better than that DASH study. So again, I think it's, hey, if you're questioning what you're eating, then you probably don't eat it. And more, again, just quality over quantity.
I agree.
Yeah.
Yeah. There's definitely stress that comes with the questioning too. So I'm like, if there's stress coming up, even if it's just perceived stress, I'm like, oh, not worth it. Let's stick with what I know and trust.
That's a good point.
Yeah. Stick with what looks like food.
Yeah, agreed.
From the planet.
And yeah, meat's already just kind of, weird in the first place. You have to get quality meat and stuff too. But I think, you know, it's everything in moderation. Like when we were talking about the drinking, I had one person describe it to me once as like buckets. Like you have all these lifestyle buckets and you're like, okay, sure. I have a big sweet tooth myself. Maybe I'm going to eat like a chocolate after dinner or a couple nights a week or whatever. But I also, you know, work out and I'm in the gym lifting weights like 7 days a week. So I think it's just like understanding who you are, what you're willing to give up, what you're not willing to give up, but making it your lifestyle, like your habitual routine. So then when you know, maybe do have friends and you go out and have more drinks, like don't get mad at yourself, like accept it. But, you know, we have to hold ourselves, I think, to a high standard. And like you said, Lauren, we beat ourselves up or we, you know, question it. Like we know when we're not doing the correct thing. So I think it's just making it your lifestyle.
Mm-hmm, for sure. Yeah. I think it's what we're doing. I don't know, maybe 80% of the time that's really making the big difference, or maybe even 90%. And then when you do the other things, the 10% of the time, don't beat yourself up and cause all this extra stress and cortisol to be running rampant. So amazing. Hannah, well, thank you for sharing so much amazing wisdom with our audience today. If we can ask you one final question, a final piece of advice, something our audience should start doing today to optimize their health.
Oh, that's good. Make some me time. Like, you know, prioritize yourself, right? Like go do something you love, that you haven't done in a while, whether it's like, even just like taking a break and going and taking a walk or whatever. I think that does more for our health than we realize. Is like, just slow down, take a break, do something for yourself and treat yourself with kindness.
Thank you for that permission and advice.
Yeah.
I will take
You're
it.
welcome.
Yes. Happy to do that.
Yeah. Hannah, where can our audience find out more about you or just connect with you in general?
Yeah, so you can find my company at TruDiagnostic.com. It's TRU and then diagnostic is singular. You can also find me at everythingepigenetics.com. Just feel free to reach out. You can find me on Instagram at Everything Epigenetics. Would love to talk to anyone if you all have questions.
Perfect. Thank you for that.
Yeah. We'll link to all of those in the show notes for the episode so everyone can easily follow you.
Perfect.
All right. Thank you so much, Hannah. This was such a blast chatting with you.
Yeah, thanks for having me.
And thanks to everyone for tuning in. We'll see you next time.